All right, if you notice here on the calculator, I've got log of 5 plus log of 4, and the reason I put that there is so we got to hit section 464 now. We got to get all those rules and stuff. This was a Google document, one of your rules of exponents and rules of logs. If you multiply numbers with the same base, you add the exponents. So you might think the log of 5 plus the log of 4, I'm almost certain in a multiple choice question, one of the first answers would be the log of 9. Is that correct? No. The log of 4 plus the log of 5 is not the log of 9. Remember what it is? If you're adding what are logs again? Exponents. So if you're adding your exponents, that must mean you multiplied numbers with the same base. So the log of 5 plus the log of 4, if I take here and hit the log of 9, I just want to show you that it's not the truth. Now see, the log of 9 is a decimal point. Think about that for a second. It makes logical sense. If I have the log base, what's the base if I don't write anything? So the log base 10, the log base 10 of 9, I've got to take the number 10 down to 9, then I have to do it with the root. Does anybody remember what the log of 5 plus the log of 4 would be equal to? Log of 20. There you go. Where'd you get 20 from? Okay, even though it says adding right there, the reason you would add them is because you're multiplying numbers with the same base. This question right here is all over the final exam. You have to change something from an exponential form to a logarithmic form. So if I'm going to change from an exponential form to a logarithmic form, remember it's log, your base goes down here, log base, answer goes right there, and this is why I keep saying, what are logs? Exponents. So it's the exponent. So what that means is to change 5 squared equals 25 to logarithmic notation. What's my base? 5. So I'd say log base 5 of 25 equals, now just to make sure everybody's comfortable with it, take your calculator, do the change of base formula real quick. When you do the change of base formula, you'll do log of 25 divided by log of 5, hit enter. And it gives you 2. The next question. I told you about this yesterday, and I'm still struggling with it with my guys in my earlier classes. Yesterday I said 3 to the negative third. Remember, 3 to the negative third, a negative 3, has nothing to do with whether it's positive or negative. 3 to the negative third is 1 over 27. Negative exponents move it to the bottom. That base right there will not be negative. Just to give you an idea, take your calculator real quick and do the log of -5. I don't know. I'm just making a number up. Log -5, look what it says.
No real answer. Sorry.
There we go. The reason it's no real answer is because that base right there is not going to be negative. Even when it is a negative number, the way we get to that negative number is we take that -1 and put it out front. So -1 times 3 to the x. Remember that flips the equation and the graph's the other way. But let's keep going here. So the log base 6 of 1 over 36. Again, what do I do to the base 6 to get it to 36? Square it. How do I move it to the bottom? Make it negative. So the log base 6 of 136 is -2. Again, do it real quick. Do log 136, make sure that 136 is in parentheses, divided by log 6, and it'll be -2. All right, same logic. Log 16 divided by 4. How did we do this one? This might be a good place for us to remind ourselves how we drew this up. What did I say do to this stuff? Circle it up. That's right. Just circle it up right there. If you can get your log on the left, everything else on the right, you just circle it up. Gotcha. 4 squared equals 6. And so that's true. Here. 4 squared is equal to 16, and that is true. Here. Does it matter the base here?
Yeah.
Look here. In this one, log base 7 of 1. Will it matter the base?
No.
Because
Zero.
anything there is in the zero box will be 1. So it's not going to be, it's not going to matter the base. All right. Guys, I'm going to take that information right there, and the next page that we're going to have to review some stuff on the next page that I'm going to do to you. And we've got to remember this, because I'm going to take this information here, combine it with the next information, and we're going to solve some exponential equations and some logarithmic equations. All right. Real quick, like this one. The reason it's on there, can anybody remind me why negative 2x plus 5 is less than or equal to 9? Why would that problem be important to us? What? The inequality. So what do you have to do when that inequality with the negative right there? Remember that? Very important. Negative 2x is, help me here, less than or equal to 4. So divide by what? Not 2, divide by negative 2. That's important because then you have to turn that symbol around and you get x is greater than or equal to negative 2. Divide by a negative, reverse the symbol. That's not a little important, that's major important. Okay? Our function notation, we remember a function notation. Where does it start at? It starts at negative 2, and how far does it go to the right? Okay, so infinity. How do I get greater than or equal to? Bracket. It's called a bracket. What if I wanted the answer to be over here, x is less than 2? What if I wanted x is less than 2 for some reason? I put my 2, I put negative infinity, but this time what would I use? Remember that?
Yeah.
All right. Quadratic inequalities. Don't know if you remember this, but guys, the first place you ever saw this was when you were in integrated algebra 1. When you were in integrated algebra 1, you solved the problem that said absolute value of 3x plus 5 is great. Anybody remember what you did with the answer? Great. Great or. You had to use the negative, but you had to use the word or. Because the original problem was greater than, you had to get 3x plus 5 is less than negative 10. Or, that's right. Or 3x plus 5 is greater than 10. The way I tried to remind you of it is I tried to say less than or great or. You'll use the word or because this is greater than. You'll use the word and because this is less than. And that's kind of how you remember it. What's the first thing you got to do? You just got to factor the equation. This first one was negative 2x plus 5 is less than or equal to 9. That's a linear equation. When you solve linear equations, you get your numbers on one side, variables on the other. When you solve quadratic equations, you set them up equal to 0 and factor them. What if they don't factor? You use a quadratic formula. I pointed there all day too, and it's not there. But anyway, this right here is the wrong equation sign. Now that got changed. That's supposed to be plus 5x minus 14. I'm sorry. It's supposed to be plus 5x minus 14. I plugged in the wrong problem there. What I was wanting you to get is x plus 7 and x minus 2 is greater than or equal to 0. Remember, when it's greater than or equal to 0, you use the word or in the final solution. Which number is going to be bigger, negative 7 or positive 2? Positive 2. So over here on the left, you're going to do, look, or, because its original problem is greater than, you go less than or equal to negative 7, or x is greater than or equal to 2. All because of the way the original problem is set up. If the original problem had been less than, I would do the same thing, but I would organize it like this one over here. X minus 5, x plus 4. Then I'd go negative 4 is less than or equal to x is less than or equal to 5. So that means it's in between those two. And again, it's all based on the original problem. I'm sorry, that says less than or equal to. It shouldn't say less than or equal to. It should just say less than. So negative 4 is less than x is less than 5. Anybody remember anything about this one? Okay, I have to square both sides. And no problem with that, so I square both sides. So x plus 3 is less than or equal to 16. So x is less than or equal to 13. All right, now, how long is it less than or equal to 13? When does it stop being an answer?
Negative infinity.
Okay, it seems like negative infinity. But remember, there's an issue right here with x plus 3 squared. Remember, x plus 3 squared has to be a positive number. If I got to put a positive in there, x plus 3 has to be greater than or equal to 0. You can't have a negative underneath the square root sign. So x has to be greater than or equal to negative 3. Because that's the way you work square root inequalities. Whatever's underneath the radical sign, you have to set that up to greater than or equal to 0, because it's got to be positive. Give me a number that's less than or equal to negative 3. What's the easiest one? Negative 4, right? What's negative 4 plus 3? What's the square root of negative 1? Yeah, there's our imaginary. That's why that doesn't work. You see what I'm saying? Square root of negative 1. It's the same concept, guys. So this answer would be less than or equal to 3, but it stops right there at negative 3. Again, look, it's pointing at the negative 3. It's pointing at the x. Again, what does that mean right there? Where is x at, like physically in the world? X is, that's right. So it's between negative 3 and 13. I'm concerned that we might look at this and think, oh, wait a minute, that's less than or equal to, so these should be brackets. I'm concerned that we might look at that and think these right here are just ordered pairs. That's not an ordered pair. That's called interval notation. That's interval notation, and it's a bracket because that's less than or equal to, comma, 13, again, bracket. Remember brackets? This question, yeah, the brackets are for greater than or less than, or greater than or equal to, less than or equal to. This is greater than or less than. Brackets are greater than or equal to, less than or equal to. All of that information, guys, packed together is what we did in 4.6 through 4.9. So now let's look at this section 4.6 through 4.9. First question says log of 13 plus log of 60. So I'm on the back of that one page, number 1A. So log of 13 plus log of 60. If you notice when I'm writing this down, I didn't put log A. I think now that we've been away from it for a while, this may make more sense to you. Guys, I'm not going to ask you to find the log A of 13 plus the log B of 60. That's not a good question. It's the log A of it's got to be the same base. When you multiply numbers with the same base, what do you do with the exponents? Add them. So it's got to be the same base. Divide numbers with the same base. Subtract the exponents. Okay, it's got to be the same base. I'm not going to give you a problem that's different bases. So I come over here. Again, guys, I'm doing this to show you that the stuff works. Log 13 plus log 60. I'm going to hit enter, and I get an answer. It seems like to me, and guys, I understand your logic behind the concept, but I'm trying to get you to see this is not the solution, nor logically does it make any sense. Remember, if I said log of 13 plus log of 60, if I added those two numbers together, I get log of 73. Well, that doesn't make any logical sense, because think about this for a second. 10 to the 2.89. Could 10 to the 2.89 be as little as 73? Could 10 squared, what's 10 squared? 100. So now I'm already over 100. You see what I'm saying? So I know that's not logically going to be the answer. Watch. It's going to be something different. If I want to write the answer here, I have to go log 780. Where'd I get 780 from? Remember when we were going through and we made the Google documents? We had the log mn is equal to, anybody? Log of m plus log n. You got to check those documents. If you look at them, guys, there was a reason we did that stuff. If you go back and look at it, it'll help you with this stuff. You may not remember this one. When we went through this one, we talked about being down in front. So I have 1/5 log base 5 of 16 minus 3 times log base 5 of x, and then plus 4 times log base 5 of y. And again, remember, this says this is log of 5, that's log of 5, that last one's a log of 5. The way we stated this first little bit right here is we said it was a down in front. It was down in front. So if we had the fifth root, of log base 5 of 16, 1/5 times log base 5 of 16, at some point that used to be the fifth root of 16. Okay, so I'm going to have the log base 5 of 16, the 1/5 root, minus, if that's a minus, goes on bottom, log base 5 of x cubed, see down in front, plus log base 5 of y to the 4th. What we did with that exponent, and the rule that we applied here, is we said that the log of m to the n was equal to, down in front, n times the log of m. So all I'm doing is I'm kind of doing this in reverse. And like Danny said right there, if it's positive, it goes on top, and negative, it goes bottom. How do you write the fifth root of 16? How do you like physically write it out? Put a little square root symbol, and put a 5 right there. Okay, so there's the fifth root of 16. X to the third, where does x to the third go? Bottom. Plus y to the 4th, because it's plus, where does that go? Top. And so there's your answer. Let me put that in parentheses. Again, guys, I'm just going through. This is called condensing. Okay, now the opposite of that is expanding. So if I'm going to condense something, that's going to go down smaller. If I'm going to expand something, I'm going to go the other way. So now I'm going to expand the natural log of 5x over 2. So the first thing I want to do is deal with this 5x. So that's going to be the natural log of 5 plus the natural log of x. How do I get the 2 on bottom? Minus natural log of 2. Because that's expansion. We're going to have to go down in front with the 1/3 right here on b. So 2b. It says log base 5 of x to the 1/3, log base 5 of x to the 1/3 power. That root is going to go down in front times y to the 6th. So if I'm going to expand this out, this is going down in front. So 1/3 log base 5 of x plus 6 times log of y. Let's just play here for a second and make sure we understand what's going on. Let's look at this 6 times, look at this 6 times log of y. Give me a number, just somebody pick any old number to let y be. 2. Could I say -2? No, because of where it's at. Remember, that number has to be positive right there. Could I say -27? No, it's got to be positive. That number right there that I'm going to plug in for y has to be some kind of positive number. So I'm going to say the log of, she said 2, so let's use 2. So that's 2 should be the same thing as log 2 to the 6th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So if I come over here and watch, it's going to work. If I do the log of 64 and hit enter, that gives me an answer. And the answer I get is 1.806. So if I take 10 to that exponent, it gives me 1.806. Okay, let's bring it down in front now. Now let's go 6 times the log of 2. Now if this is the same thing, what should happen? Same answer. That's certainly good. Okay. What about 6? What's another way we could look at 64? Give me another way to break up 64. 4 cubed. So I should be able to go 3 times the log of 4. Excuse me. Again, same answer. Give me something else that multiplies together and give me 64. 16 and 4, 8 and 8. Let's do some 2 and 32. Let's go with 2 times 32. So what should I come up here and write? I should come up here and write log of 2 divided by plus. Add a plus. Log of 32. Same answer again. How many times can I keep breaking this up like that? Log of 128. Anybody? Somebody tell me what to put next. Log of 28 minus. Wouldn't it be 2? What's 128 divided by 2? It's log of 128 minus log of 2. That's the same 1.806 answer. Because you're gonna have to take and you're gonna have to do this, son. You have to take a calculator and figure out some logs that are the same. 3a. Log 5 of 3x plus 9 equals 2. I got my logs on one side. I got everything else on the other. What was the method we said here? Say it over and over and over when we're in this section. Okay. Take the exponent and circle it up. Yeah, I'm going to circle this up. I'm going to say 5. I'm going to do it with the 2. Five is the base. 2 is the exponent. 3x plus 9. 25 equals 3x plus 9. So if 25 is equal to 3x plus 9, help me, 3x equals 16. Divide by 3, x is 16 thirds. 16 thirds. Guys, exponential equations, you have to check. You got to take that 16 thirds and plug it back in. 16 thirds. 3 times 16 thirds plus 9 is 16 plus 9. 16 plus 9 is 25. So this says the log base 5 of 25. That was one of our warm-up exercises. I did that on purpose. Log base 5 of 25 is equal to what? 2. Log base 5 of 25 is 2. It works. The thing you got to be careful of, does anybody remember what it was called when I had a solution that algebraically works, but when you plug it back into the original problem, it doesn't work? Begins with an E. There we go. Extraneous. Good word. Extraneous solution. Real quick, 3b shouldn't be that difficult. What's 5 to the 4th? 625. Yeah. So letter B, number 3b is 625. Letter C, I'm going to have to change. I'm going to have to change 2 times the log base. What is that number? 3? Log base 3 of x squared is equal to the log base 3 of 4 times x plus 8. Okay, what concerns me here, what concerns me about this problem is how we look at this problem, and we still want to battle with. Guys, I'm just not going to ask you this question. I'm not going to say the log base 3 of x squared and the log base 4 of something else, because they got to have the same base. Once they have the same base, I got logs on both sides, so now what can I do with the logs? Just drop it out. So x squared equals 4x plus 32. Warm-up exercise. How do you solve a quadratic equation? What if it factors, though? X squared minus 4x minus 32 equals 0. Keep me going. X minus 8. X plus 4. X equals 8. And x equals negative 4. But look at the original problem, guys. In the original problem where number C says 2 times the log base 3 of x, I'm on the review on the back, 4.6 through 4.9. 3C says 2 times the log base 3 of negative 4. Does that make any sense? You can't have a log of a negative. Guys, even though mathematically this is what works out as an answer, this can't be true. This is an extraneous
Solution.
solution. Because when I plug it back into right here, let's just use your calculator real quick and do it. Try to do the change of base formula on the log base 3 of negative 4. Go log negative 4 divided by log 3. No solution. It's not going to work. So even though, guys, even though algebraically -4 is one of the solutions that you get, it doesn't work in the original problem, so you have to cancel it out. That's some pretty good math stuff right there. Letter D. Letter D is natural log of 3x plus 1. By the way, what is the base in natural log? That's log. Natural log is e. So equals natural log of x plus 5. Yeah, just move it to the other side. Got your logs. Now I can just drop them. So 3x plus 1 equals x plus 5. 2x equals 4. X is 2. What should happen when I plug 2 back in? It's 3 times 2 plus 1. 2 plus 5. Natural log of 7 is equal to natural log of 7. Last section. Okay. Problem number 4A. We started the day out with a linear equation. And when we had a linear equation, we got our numbers on one side, variables on the other. I had a quadratic equation. How did you solve quadratic equations? Quadratic formula, or you factored it. We had the problem that had a square root in it. How did you get rid of the square root? Squared it. We have this problem with absolute values. You have to know with absolute values, you're going to get 2 solutions. Guys, it's just the way you solve it. This will be a very good answer to a good question here, and it'll really give me some confidence that we've done something here and we've got the concept. Look at this problem. It's got a variable and an exponent. I have to solve equations for exponents. What do you use to solve equations for exponents? Log. That's the whole. Guys, if it wasn't for that concept right there, if that variable wasn't in the exponent right there, we would have never talked about logs this year. We wouldn't have done it. There was no need to. We knew how to solve quadratic equations. We knew how to solve cubic equations. We know how to solve square root problem. We know how to do everything except for solve for exponents. So when we have to solve this for this exponent, I have to get it down to it's all your exponents on one side, everything else on the other. And so then I have 6 to the negative 0.2x is less than or equal to 36. So what's my base? So log base 6 of 36 is less than or equal to negative 0.2x. What's log 6 of 36? 2. So 2 is less than or equal to negative 0.2x. What do I divide by? Say it right. Negative 0.2. Why is that significant? Warm-up exercise. It'll flip the sign. So when you divide by negative 0.2, I go 10. So I'm going to go x is less than or equal to, see it's eating the x and now it's pointing at the x. X is less than or equal to negative 2. How long does that happen? It goes to infinity. The reason it goes to infinity is because the smaller this number gets, that's going to be 36 minus 3. It's going to be less than, and that'll be a positive exponent. It'll keep going bigger and bigger and bigger. Everything will be fine. Interval notation, somebody? Negative 10. Bracket or parenthesis? Bracket, comma, negative infinity. I don't have to put a bracket on this side. For B, e to the negative 0.07t 0.07t is greater than or equal to 8. Again, I'm solving for a base E problem, so I'm going to use the natural log. The natural log of 8 is greater than or equal to, natural log of 8 is greater than or equal to negative 0.07t. Let's take the calculator here. Divide by negative 0.07, divided by negative 0.07. T is greater than or equal to natural log. To get your natural log button, it's over here. It's ln 8 divided by negative 0.07. I get negative 29.71. Negative 0.0, a negative times a negative is a positive. This number here will be, this number will be positive. And so when I multiply negative 0.07 times negative 29.71, this guy right here, because it's negative, a negative times a negative is a positive, it'll always be greater than or equal to 8. Goes on to positive infinity. That was what, 4b? Last two. 4c. Log base 4 of x plus 6 plus log base 4 of x is less than 2. So the first thing I got to do is I got to rewrite this. So this is going to be the log base 4 of x times x plus 6 is less than 2. We good with it yet? Log base 4 of x squared plus 6x is less than 2. Circle it up. Circle it up. X squared plus 6x is less than 16. So x squared plus 6x minus 16 is less than 0. So x plus 8, x minus 2, less than, so it's going to be negative 8 less than x less than 2. Now you might think that's good enough. Less than, so I wrote it like this, but let's think about this for a second. Up here where it says log base 4 of x, tell me about that x right there. That x sitting there has to be what kind of number? It's always got to be positive. So even though this mathematically works out that way, guys, it stops right here, or I guess I should use a parenthesis, it stops right here at 0. Because it can't be negative. That can't be negative. Log base 4 of x can't be a negative number. So even though mathematically all these numbers right here, they say they were going to work, they can't work because that's a non-real solution. So your real answer, and this is talking the whole day to get to write this right here, 0, 2, parenthesis. I'm afraid right now we might look at that right there as an ordered pair. Guys, that's not an ordered pair now. That right there says 0 is less than x is less than 2. What if I wanted it to say less than or equal to? I'd use a bracket. All right, last one. What do we got? Log base 3 of... So I got it down to 3. So I'm going to circle it up. 2x minus 1 is less than... come on. 9. 2x minus 1 or plus 1? less than 2. So when I circle that up, I get 2x minus 1 less than 9. 2x is less than 10. X is less than 5. Where does x is less than 5 start at? 5. How far does it go down? Use a math term. Infinity. It goes to negative infinity, doesn't it? But look, a lot of that doesn't make sense. Guys, this right here, tell me about this number right here. 2x minus 1 has to be what? 2x minus 1 has to be what kind of number? It has to be a positive. Right? It can't be a negative. So that's got to be, the number's got to be bigger than 1/2. I can write all these numbers down here to negative infinity. But guys, all of these from negative 1/2, from positive 1/2 down, all these numbers are extraneous. Because they don't even work when you plug it in right there. Think of a number that's way down there. Plug in a negative 10. If I plug in a negative 10, what's 2 times negative 10? Minus 1? Negative 21. So it would, on your calculator, you would be plugging in the log of negative 21. Is the log of negative 21 going to work? No, it's not going to work. So guys, you've got to know to check for extraneous solutions right here. So this will be x is less than 5, but guys, it's greater than or equal to 1/2. Ooh! Come on. Do I do 1/2? Bracket or a parenthesis? Do I do 5? But you have to take what's in parentheses right here and understand that thing has to be greater than or equal to 0. Tough stuff right there. Tomorrow I'm going to show you how to use the stat button on your calculator. And here's stat. We're going to input 2 lists. We're going to input those 2 lists in problem number 5. If you want to try it, we're going to input year. This will be the year 1. We're just going to put these numbers in 2, 3. I'm just getting those straight from that table. I'm going to plug in the 2 equations, y equals 3 to find the intersection. That's the solution to the system. I'll plug that into y1 and y2. That's problem number 6. And then the last thing we'll do is that section there on the comments. There'll be a couple of questions on probability, but for the most part, I'm taking the probability out of it.